start next module, module 3, transformers and domestic wiring. Today, as a first topic, we are coming up with the transformer, single phase transformer. First, let us discuss the necessity of transformer and principal operation. Transformer is a static device which transfers the electrical energy from one circuit to another circuit without any direct electrical connection or without any change in frequency through the process of electromagnetic induction. This is what transformer means. Now, what are the necessity of transformer? There are so many requirements, there are so many advantages of using transformers. That is, the first one is voltages need to be stepped up, stepped down. Full load efficiency in the order of 97 to 98% is required. So these are the there are applications of transformer. Let us come to the working principle operation or principle of operation or working principle of a transformer. The transformer works on the principle of mutual induction, which states that when two coils are inductively coupled and if current in one coil is changed uniformly, then an EMF gets induced in the other coil. In its elementary form, it consists of two inductive coils which are electrically separated but linked through a common magnetic circuit. The two coils have high mutual inductance. The basic transformer is shown in the screen. One of the two coils is connected to a source of alternating voltage. This coil in which the electrical energy is fed with the help of source is called primary winding. The other winding is connected to a load. The electrical energy transformed to this winding is connected to the load. This winding is called secondary winding. The primary winding has N1 turns. You can see on the screen N1 number of turns, while the secondary winding has N2 number of turns. When primary winding is excited by an alternating voltage, it circulates an alternating current. This current produces an alternating flux, which completes its path through common magnetic core, as shown in the dotted lines in the figure. Thus, an alternating flux links with the secondary winding. As the flux is alternating, according to Faraday's laws of electromagnetic induction, mutually induced EMF gets developed in the secondary winding. Symbolically, the transformer is indicated like this. We can see that. I'll show. P is the primary winding while S is the secondary winding. It's always designated like that. The two parallel lines in between two windings represents the common magnetic core. Thus, there is no electrical contact between the two windings and electrical energy gets transferred from primary to the secondary. One more question comes. Can DC supply be used for transformers? The DC supply cannot be used for the transformer. The transformer works on the principle of mutual induction, for which current in one coil must change uniformly. If DC supply is given, the current will not change due to constant supply and transformer will not work. Practically, winding resistance is very small for DC. Actually, it will be very small, winding resistance. For DC, the inductive reactance XL is 0 as DC has no frequency. So, total impedance of winding itself is very low for DC. Thus, winding will draw very high current if DC supply is given to it. This may cause the burning of windings due to extra heat generated and may cause permanent damage to the transformer. There can be saturation of the core due to which transformer draws very large current from the supply when connected to DC. Thus, DC supply should not be connected to the transformer. Next, we can come to the construction. You can see the construction here. There are two basic parts of the transformer. One is magnetic core, other one is winding or coil. The core of the transformer is either square or rectangular in size. It is further divided into two parts. The vertical portion on which coils are wound is called limb, while the top and bottom horizontal portion is called yoke of the core. These parts I have shown here. Core is made up of laminations. Because of laminated type of construction, eddy current losses gets minimized. Generally, high-grade silicon steel laminations are used. These laminations are insulated from each other because you know that the property of an insulator by using insulation like varnish. Laminations are overlapped so that to avoid the air gap at the joints. For this, generally L-shaped or I-shaped laminations are used usually. The cross section of the limb depends on the type of the coil to be used, either circular or rectangular. The coils used are wound on the limbs and are insulated from each other. To decrease the leakage flux and to have high mutual inductance, the two windings are split into number of coils and are wound adjacent to each other on the same limb. The coils are made up of conducting material like copper. You can see here, it's shown in the diagram. The core provides the low reluctance path to the flux produced by the primary, while the windings carry the currents necessary for the functioning of the transformer. This is about the construction of a transformer.